from Anveshana Academy, Bangalore, India. Okay, dear students, in the last class we discussed about what is unification. Okay, so with many examples I tried to explain you what is unification. Dear students, so today I am moving towards second approach, that is reductionism. Okay, so the first approach we have discussed, that is unification. Today I will move towards next approach in physics is reductionism. So what is reductionism that you can see now? Explaining an event or a mechanism or a happening or a property with the help of atoms or molecules from the basic level. That is known to be reductionism. What is reductionism? Explaining an event or a mechanism or a happening or a property with the help of atoms or molecules from the basic level, that is known to be reductionism, dear students. So what is reductionism? To understand that, I will take some examples and I will try to teach you, dear students. What is that? You can see now. An example I will take. In thermodynamics, we are studying the properties of the system in bulk, like temperature or internal energy. You can take some properties. We are studying these kind of properties in bulk. That is known to be, that is not a reductionism. Reductionism means what? We are going in depth or in detail study of a system. That is known to be reductionism. How it is now? I can study system in bulk one way, or else I can go in detail with the help of some theories. That theory you can take a kinetic theory. Individual particles of the gas or a substance we are going to study. Based upon that, we can tell the properties of the system. That is known to be reductionism. So what we are doing? We are going to do kinetic theory, analysis, statistical mechanics to understand the properties of the system. That is known to be reductionism now. That means what? We are moving towards molecular level to understand the properties of the system. That is known to be reductionism. Instead of taking some bulk properties or macroscopic properties, temperature or volume or pressure, what we are going toward the molecular level, and we are going to explaining the approach. That approach we can call it as a reductionism. What is that? You can see now, dear students, in our day-to-day life you can see many observations or many happenings or events are happening day-to-day life. Okay, what we are doing now? You can see here now one examples in our observations in our day-to-day life. You can see here now heating. So in your home you can take you are boiling some water. You are boiling some water with the help of heat. This is an observation or event. So if you are telling yes, just if you are telling heat is getting transferred, that is what? It is, you are telling it in terms of bulk. Is that the temperature may be this much or internal energy may be. You are telling randomly or in a bulk. But that is not a reductionism. Reductionism means what? We are going to in detail to explain that event or observation. How it is, that you can see here now. So you are telling in bulk, you are telling heat is getting transferred. That is what? In bulk you are telling. But in reductionism, you are telling what type of heat is getting transferred. What is the reason behind this heat transfer? Whether it is, in what way it is transferring, whether it is in transferring in conduction or convection or radiation. So like that, in detail or in step by step you are entering into that event and you are studying. That is known to be reductionism. Now you can take here now. In general you can tell heat transfer is getting happen, but what type of heat is getting transferred? Whether it is conduction. If it is a conduction, what type of what is the reason for that conduction heat transfer? So that conduction heat transfer is explained by one greatest scientist. That scientist is Fourier. Okay, he given one law towards conduction heat transfer. That law we can call it as a Fourier's law of conduction. What he explained? He explained heat is getting transferred. You can take it here now. So you are supplying heat here now. This is a metal plate. That metal plate you can take it as solid. It is a solid, right? Now you are supplying heat here. Now heat is getting transferred through a molecules. Here are the, in the metal plates there are molecules. That molecules, what they will do, they will absorb the heat from high temperature region, and they are transferring heat from high temperature region to low temperature region. But the molecules may not alter their position, but they may vibrate. But what they are doing, they are transferring heat. So that means what? Molecular level you are studying now. You are telling the molecules, they are transferring heat from one part of the substance, to the another part of the substance, or one part to another part. But the molecules are at under rest, but they may vibrate. They are transferring heat. That type of heat transfer can called as a conduction heat transfer. That is well explained by Fourier. So what is that law? You can see here now, Q is equal to minus K into dt by dx. So this is what? Conduction heat transfer. Now again, so now heat is getting transferred to water. Assume that water. So this you can call it as a case 2. You can call it as a case 2. If the water is getting transferred from one part of the substance to another part, if it is moving in upward directions, heat is getting transferred. What is the reason to transfer heat in this fashion? Because here in the second case, heat is getting transferred in medium. In media, what happens? The molecules, you can see here the molecules, they will absorb the heat and they will try to come up, and they are going to interact with some other molecules. Then the heat will be transferred from one molecule to another molecules. That heat is getting transferred from individual molecules to individual molecules, or group of molecules to group of molecules. So that is nothing but what? Macroscopic and microscopic approaches we are having in thermodynamics. That means what? Heat is getting transferred, you are telling. That to what? In media, that heat transfer can call it as a convection. Convection heat transfer is a heat transfer in which the heat is getting transferred from one part of the substance to another part of the substance through a media. In that media, what actually happening? The molecules are moving from one part to another part. If the heat is getting transferred in that fashion, that we can call it some convection heat transfer. That convection heat transfer is well explained by a scientist again, that is Newton. Then he has given a law, that is we can call it as Newton's law of cooling. Then how to calculate how much amount of heat is getting transferred? That is calculated with the help of a Newton's equation. That Newton's equation, that is Q is equal to HA into delta TDS. Students, see here now what in detail you are going to study. Initially it was just one observation, heat transfer, but you are going step by step to the molecular level. That we can call it as a reductionism, dear students. Okay, that is convection heat transfer. One more example you can take. IC engine. IC engine, if you are taking a small portion or a small mass, and we can tell the properties, like you can tell the temperature or pressure. That is what macroscopic you can call. But reductionism means what? You are going in detail. You will go to the molecular level. You will try to measure the properties of the molecules, and you are telling the properties of the system. That is what reductionism, dear students. Okay, to understand better, I will take some live examples, day-to-day activities. I will try to explain you what is reductionism, dear students. Okay, so one example you can take it here now. Bus is moving. It's an observation. It's an observation or an event. It is happening in our day-to-day life. So this observation we are going in detail, step by step, to the basic level or micro level, that is known to be reductionism. How it is now? Initially it was a bus. Okay. Then what I will do? I will try to study the bus, in parts of the bus or engine. Then we are going to study what is the wheel, what type of tires they are using, what is engine cylinder and piston, what are the properties of that fuel, what they are using for an engine. Either it may be lubricant oil or it may be fuel. We are going to study in detail, step by step, how it is, that you can see, dear students. So if you want to purchase a second-hand car, what you will do? You will not see outside. You will not see outside and you will not become conclusion car is good. No, what you will do? You will go to that car and you will see the body of the car, tires of the car, engine of the car, okay, then lighting system of the car, music system of the car, chassis, like that. What in detail you are going to study there. Once it's good, then what you will do? You will purchase that second-hand car. Like that. What reductionism means? What? We are going in detail, step by step. That is known to be reductionism, dear students. That's one live example or observation or happening or event in our day-to-day life we can consider. So you can consider second example, playing in a cricket. When it comes to playing in a cricket, for outside he is playing in a cricket. That is what? It's outside it looks like that, but what actual reductionism tells, it tells what is that cricket, he is playing a cricket, then what type of force is putting on that cricket, okay, at what speed that ball is moving, okay, so then what type of materials they use for making that ball and bat, okay, and what type of gravitational force is acting on it, okay, what will be the viscous force in the air, because the ball is moving in the air, right, what, how much amount of viscous force is there, like that in detail we are going to study step by step in a cricket event. That is known to be what, reductionism. Okay, reductionism means what type of material is used to make a bat, what is the material used to make a ball, and what is the viscous force in the air, what, how much amount of force is putting on it, and in that how much force is act by the gravitational force. These all things in detail we are going to study. That is known to be reductionism, dear students. You can take one more example, lamp. So the what is that lamp, how it lights, and what is the reason behind it, what type of materials they use to make lamp as well as the lamp, okay, and they are going to lamp, if they want to light, they are going to use some oil, what type of oil they are using, okay, and what are the properties of that oil, okay, so what is the cost of that oil, in detail we are going to study. That is known to be reductionism, dear students. Reductionism means what, in simple way, in simple term, any observations in our day-to-day life, you can take observations or event or happenings, we are going to study in detail step by step, that to basic level. That is known to be reductionism, dear students. Okay, now I will move towards next topic, that is scope of physics. So what are the scopes are there around us, that we are going to study it now. The scope of physics is very broad and covers a wide range of many branches. What are that we can going to see here now. The scope is scope of physics. Next topic, scope of physics. Physics is not only limited, okay, it is a broad and covers a wide range of many branches, namely classical mechanics, thermodynamics, electrodynamics, quantum mechanics, optics, and relativity. You can take any event which are happening in our day-to-day life, there is a physics, day students. The physics is, it is having a broad applications, or it is having a scope in many area, domains or areas. So these are some areas. Okay, here we can see some more areas. What are those? Classical mechanics, electromagnetism, thermodynamics, quantum mechanics, astrophysics, particle physics, relativity. Next, condensed matter, AOMO physics, biophysics. What is AOM? Studying the structure and interaction of atoms or molecules. Like that, it is, we are having n number of applications. There is a lot of scope in our day-to-day applications. See here now some more applications. Physics, scope of physics. Okay, we are using in classical mechanics. Classical mechanics means what? We are using Newton's law. You can see some examples. When the block is falling down, right, why it is falling down, at what velocity it is falling down, at what force it is falling down, what is the weight of that block, that we can going to study it with the help of a law. That is what? Newton's law. Again, the physics scope is there. You can take a pendulum. When it is pendulum is moving, right, there is a conversion of energy, kinetic to potential to kinetic. Okay, the energy conversion will take place. Law of conservation we have studied. Again, there is a scope of physics. You can take, dear students, condensed matter and physics. We are developing our day-to-day life. We are using semiconductors, right, in your mobile or any electronic gadgets what you are having, right, we are using semiconductors. You can see now semiconductors now, or else you can see some chips or some semiconductors we are using in our day-to-day life, right. Beyond this, physics is there. Okay, so beyond this semiconductors, there is a application of physics is there, students. Not only that, I told thermodynamics. When it comes to thermodynamics, right, the best example we can take IC engine. To develop or to design IC engine, the physics is very important, dear students. Not only that, you can take atomic, molecules, and optical physics. What is that? You can see now laser welding. So laser is the, right, laser is again what? Application of physics. Laser you can take. Okay, laser cutting you can take, laser welding you can take. Not only that, dear students, in your hospitality, in your medical field, okay, so we are using scanning machines, right. These are what? They are using laser to scan. This is what? Application of physics, or we can say scope of physics. This physics having a broad applications in our day-to-day life, dear students. To understand better, I will show some more examples for you, dear students, that you can see here. Okay, so here wind energy, conversion of kinetic energy to electrical energy, there is a scope of physics. When water is falling down, right, at what velocity it is falling down, what will be the viscous force, that is physics. Water spraying, if you want to design agriculture machines, tractors, physics. If you want to draw, physics is there. If you want, you can see here now, the hydraulic lift or robotics, physics is required. You can take agriculture land, solar energy. Okay, so they like that you can take any applications. There is a temperature, thermometer, there is a physics. You can take railway. Okay, physics is there. You can take when you are lifting some weight and you are moving, physics is there. You can take heater, bus, like that. You can take many examples, dear students. See here now, like that we can get many examples we can see in our day-to-day life, dear students. Okay, so it is not only limited to some applications. You can see there are a number of applications we can get in our day-to-day life, dear students. Battery or a drum lifting, you can take a pen. Wind system, you can take boxing, you can take parachute design, you can take a swimming, you can playing, we are playing football, right? You are, when you are moving with a bicycle, when you are applying some force and tug of war, you can see playing a guitar. Okay, pushing the trolley in your shopping mall. Okay, so like that. Okay, like that parachute. Okay, like that. Okay, you can get n number of application of physics. So dear students, herewith I request you, please do subscribe my channel, like and do comment, and please help me to support. Please support me to do more and more video. I hope you will not forget to subscribe my channel. Thank you.